So we're back in Dave Van Slyke's shop, and I warned you that you're going to get a look at this project complete. And when I say complete, I mean complete. Unlike yours truly, who takes things to functional, Dave took this thing to as far as he could go. So salute to Mr. Van Slyke. And I'm not the only one that takes things to functional, because I've got my good friend Cy Swan here, for whom functional is sometimes survivable. Okay, functional, survivable, these things are sort of about the same thing. And as you've seen in Ken's shop, his woodwork is way beyond functional. It's perfect. And so Dave has taken that aesthetic to restoring this old drill. So Dave, I want you, we want you, we're going to talk about the fact that you had this in your shop from Cy. You had it in your shop from Leonard Moog, your friend who was in Montana at the time, who's worth his own video, but Leonard passed away about 4 years ago. He was a thrasher. And so from Leonard to Cy, and Cy to Ken, and Ken to my shop, and finally we found somebody that would do it. So we're going to bring...
Dumb enough to do it.
Yeah, with time and the ability. So Dave, come over here, and Nate's going to film you talking about the details that you showed us in process and now are in their glory.
This is a post drill. This is not a drill press. And so what does that mean? Well, a post drill was designed to be mounted on a post in a typical shop or a barn or that sort of thing, a blacksmith shop. A standing drill press was a machine tool. And they did the same thing, but a standing drill press had the multiple pulleys you're talking about. It had back gears you could slow way down for drilling great big holes or if you're in really hard stuff. This was kind of a universal one-size-fits-all, and it was a go-to machine.
But this is one size up from the one that you gave me to wire brush and paint,
yeah,
which is the same thing, less of it.
The year this was produced, they advertised this as the heaviest drill in the market.
Oh,
And they took pride in that. Yeah, this is about a 400-pound drill altogether here.
Takes a pretty good post. And you've got it on a pretty good post.
We got a pretty big chunk of wood that had to be the right scale to even look right with it.
Look at that.
So this was not just like shops, but farms would have one in their shop for...
I would say most farms wouldn't have this magnitude of a drill. This is a blacksmith shop. This is
And a good big one.
a big blacksmith
Right.
shop.
I see.
Because I've got a couple other post drills and they're minuscule compared to this.
Yeah, you could lay them on the table and drill a hole in them.
Right.
So, you remember the box of parts.
I remember I tripped on them for 2 years.
Yeah.
And it was just frustration. I thought, the shop space is worth more than the parts. Dave will take this.
And the first thing was just to try to figure out what am I looking at. I knew it was a drill, but that was about it. So I had to, what is it? I knew, okay, it was a Canedy Otto, on and on I went. I'm not going to repeat the story of how I got into the narrative from Peter back there in Boston and saved the day because he restored one and had detailed pictures and detailed narrative of taking his all apart, and it was a lifesaver. And so what I was able to figure out, which on my own would have been nearly impossible, was how some of this gearing worked. There's catalogs I could look at, see what the original parts kind of look like, but those are pretty rough. They had not a lot of detail. He was able to show me, in fact, I had him go into his shop and we did a FaceTime where he could get up close, and I actually had him count teeth on this gear for me.
So there's got to be people watching this that have never seen anything like it. What was this? When did it show up? What did it relieve people from? What's this thing for, Dave?
It drills holes.
It drills holes.
Yeah.
In metal.
In metal.
Or anything else.
And in anything else. In your fingers, it'll do that as well. Wood, metal, of course, anything else along the way. Uses a twist drill bit, they call these. Goes into this, which is called a chuck. In fact, let's chuck this up. Now we're in 1908 unmotorized version.
Wow, is this power feeding? Yeah. Oh,
It is.
That click
Yeah.
says it's power feeding.
In fact, let me lock this in and watch. Okay, well, you guys see what's happening. Okay, this makes the quill go up and down.
Okay.
Okay, they call it a mandrel on this, but it's a quill. Same difference. So as you be drilling by hand, think about this. Okay. And you gotta feed this down at the same time. Oh, that's a lot of work, and that's a lot of monkey motion there. So what we do is we lock this in, and now watch what happens here.
Here it's moving.
And if we're drilling wood, that'd probably be a good speed.
Yeah.
You could do that for fun, but it's up to you, whatever you want to do.
Yeah, let's put a piece of wood on there. Let's make a chip.
Okay.
Faster.
That's going to put a blister on my finger.
175 to 180 revolutions per minute is what your target is. So
How am I doing?
see if you can hit that. You're hitting about 4 RPM, I think.
There it goes, boys. And the friction's increasing.
And that's with wood.
That's with wood.
Think about how fun it's going to be with steel.
Put a piece of steel on there. Man, oh man.
Don't weaken.
Yeah, don't back off. Keep your foot down on the accelerator.
I'm going to guess that this is probably an apprentice tool. you
Yeah,
know?
yeah, absolutely.
You throw the
Go
key
drill
on
some
here,
holes, son.
Say, go drill me some holes.
Yeah.
And the journeyman would get it all set up, and then the kid would be the power source.
And then running it backwards.
Yeah, actually, we can just take it undone from the power feed and just bring the quill right up out of
Okay.
battery bay.
Now, let me feed it by hand and see how the
See how fun
the
that would be?
friction relates to the. Yeah, so you would have the latitude of adjusting for the strength of your right arm and the hardness of the material and the sharpness of the bit. And wow. All right, Dave, show us. What else do we need to know here besides the narrow passes you had to go through to make it?
It was missing some key elements, and we did a whole detailed discussion about this, and you can see why that's so important to actually use in this machine. This is the power feed mechanism.
Okay.
And so,
And that was just gone.
Yeah, get it positioned. This is what they call an eccentric. And so, as this slides back and forth, it moves towards center there, which means it's going to go around and do nothing. Or you're going to bring it out, and the further out you bring it, the more motion it gets in this whole operation. And so
Per revolution.
That's the speed of the feed happening. Make sure that we're going to not hit.
Yeah, okay. That's it, huh?
The rest of it belongs to you.
Oh, thanks.
May the force be with you.
Yeah. Is that 180 side? Oh.
I can't count that fast.
All right, we're beginning to make contact. There we go. Thanks for that sharp bit, Dave. And if I had long hair and it dropped onto that gear, would I soon know it?
43 and half a minute.
You're timing him.
82 or 86.
We've done it. We've done it.
We made a hole. Look at that. Wow.
Now I don't have to run it backwards, right? I mean, we can
No.
pull the quill.
Yeah, let's pull the quill. I unlock it here, and it should pop up out of there.
Look at that.
That is cool.
It is cool.
Amazing.
Yeah.
That is too cool.
Well, let's put a little bigger bit in there that we have a pilot and do it again, should we?
By hand?
Yeah.
Absolutely.
Yes, let's do that.
You should do that. Absolutely. Now you can see why my theory this is an apprentice machine comes in.
Yeah. Yep. Learns all kinds of good stuff.
Yeah.
The first hour.
So unlock that. I just locked that because this thing is wore out enough, it just wants to drop.
Yeah.
And so there you go. Lock her into place.
Lock.
May the force be with you.
Thank you. That's more like it. You gonna laugh at me if I change arms?
No. I'm going to think you're wise.
I'm not doing it. I'm not changing arms,
I
boys.
told you you're going to ice that shoulder. Wow. Now for your project, that'd be how many more of these you would have done?
Wow. That is so cool. I'm a little sweaty, but that's very cool.
Yeah, let's move into some fresh meat. I'm going to power drive this and watch it work that
Okay.
half-inch under power,
Okay.
which is way funner.
It took 66 seconds.
And so Do you think that the original one was calibrated up there so they could judge, or
Mm-hmm.
everything
I don't
was
think so.
hip shooting? It's going to vary with sizes of bits.
Mm-hmm.
And what I found is, even with this dry belt here, this is pretty weak kneed because you lose power here pretty fast because this is a real inefficient way of transferring power. The original spindle on here had a V-belt, and if you wanted to do this for real, you'd want a V-belt drive.
Yeah.
Just because all that horsepower is going to get, well, most of it.
A lot of it.
What, probably 80% is going to get to that work. Where this, I don't know what the percentage is, but it bogs
Yeah.
down pretty
Yeah.
quick.
Why is that? Because belts are slipping and sliding?
Yeah,
so
it's a
much?
surface area thing. And this is sticky because I spray on a belt dressing. They used even molasses back in the day. Anything sticky, you'd throw that on there. Messy world back then. I'm
Yeah,
sure.
man.
They had stuff all over there, molasses and grease and sawdust and who knows what.
And was this hooked up like with a line shaft? Like
Yeah,
the whole shop?
the
Is
way
that
it's set
how
up
it
now is what I have here is a short stub of what in a real shop would be a long, continuous, sometimes hundreds of feet long, at how big the shop is.
Yeah.
But in most shops, usually 40, 50 feet, depending on, that's, I'd say the
With
average.
power dropping off at each station.
And you'd have, instead of this little motor here, you'd have like a 10-horse motor somewhere. That was maybe.
Water wheel.
Or a
could be a
steam
water
engine
wheel.
or a water wheel. That
Yeah.
one that they have down in California had a water wheel, and now it's a little motor that they run that runs their power shafts.
It could be mule drive.
Yeah, that's
you
right.
know,
Horse on a treadmill.
For the guys
The
doing
one-
sorghum and all that sort of thing.
The drill that I had that was like this but different had a belt up there with 3 or 4 pulleys, a little narrow belt that changed the feed speed.
Yeah.
So this is much more positive.
Now we're logging. There we go. I feel like John Henry commissioned the steam drill. I don't think I did too bad.
Except this will do that all day long and it doesn't care.
Oh,
We have drill.
we have drill. Beautiful. Well, if that's not a win, I don't know what a win would look like. It's a thing that not everybody has the same skill set. And when you find the guy with the right skill set, something gets done that would have languished until entropy claimed it. And entropy had nearly claimed it. There were parts missing and there was rust and there were bearings to recast, but it's just so slick that the resources are available for somebody to learn how to do something if they want to bad enough and if they've paid their dues. And Mr. Van Slyke has paid his dues, and boy, he made it happen. Thanks for watching Essential Craftsman, and keep up the good work.
Champion, Buffalo are ubiquitous. Those are, when you see post drills around in antique stores, or that's what they are. You know, and that was the one you'd probably see in every barn, in every workshop.
I'm sure Little Giant probably had one.
Yeah, I bet they did.
So this is Canedy, you said?
This is Cadedy Otto, yeah.
So were they big in the market, or did they come and, like so many others, just come and go, or did they occupy some space? Or
No,
do you
they're
know?
big. Yeah, I don't know the full history of them, but they had a big, thick catalog of all kinds of stuff. And this is the biggest post drill they made. They sold at the same time, and you can look this up on in fact, Keith Rucker's site, he's got some original catalogs on there. You can download the PDFs, which I've done quite a bit of with this project. And they have this exact drill in a freestanding pedestal version, which would really be a drill press.
I see.
So you
I
have
see.
a post
Same
drill and drill
mechanism.
press. Yeah.
Okay. Oh, so the thing that jumps into my mind is blacksmith shops had dirt floors. So you would put it on a post instead of have it wobbling around on the gravel or the dirt or the bricks or whatever their floor was.
The other thing is shop space is always a premium.
Yeah.
And look what you can do with that.
Yeah, that's right. That's right.
And of course, you immediately clutter that up with something.
Oh yeah, store something. You would store first. You would store stuff here, and then you would put it underneath.
And that gets shoved off and then pushed under there.
So talk to us about this glorious electrical contraption. That's
Okay,
what
I gotta
really
get up
pushes
and watch
Si's
this
button.
again.
Okay.
Si's got to come over and watch that. He loves to play with electrons.
Well, it starts up here. You know, it depends on how you want to go with this. It starts here, and if you make the decision, okay, hand drilling, and again, you're going to get to drill some steel.
Oh, thank you
because that
so
has
much.
to
Thank you,
happen.
Dave. Yeah, thanks.
If you don't leave with a
Throbbing
I
deltoid.
have not done my job. In fact, I'm going to ice that tonight. Ask me how I know this. So we decided somewhere along the way in 1908 that, we drilled one hole with that and said, okay, we're calling the factory. We're getting this belt drive. And so we got this pulley, and it's being driven off our overhead line shaft. In a blacksmith shop, this that doesn't have a continuous one, this would not be an unusual setup, is to have what we have, a counter shaft setup here, which means that we're going from the speed of this motor, 1725, that's got to get to 175 to 180 here. And you can't do that in one step.
What was that, revolutions per minute? Or?
Revolutions per minute, I'm sorry, yeah. And so to get at one step, you'd have to have, well, it'd be difficult.
Unworkable pulley
It'd be
size.
really, and it's just a ratio thing. And so normally what you do is you would drive a counter shaft, and the counter shaft would be matched to what you're doing here. And that's how an overhead line shaft works, is you have one continuous RPM. That's pretty low. The old ones were probably about, 300 RPM probably, Si? The overhead
I
line
really
shaft?
couldn't
Okay.
say.
That was continuous, and so whatever machine you had would be rated for whatever RPM they wanted that machine.
Step it up or step it down.
If you're running a drill press or post drill, 175 to 180. If you're running a saw, you might want to run it up to 2,000, depending on the size of what you're doing, or a router. They had routers back in that time. And so you size your pulleys and your configurations to that. And a lot of times you'd see the overhead line shaft power and everything, and then there'd be a belt going over to another shaft over here that then would be pulleyed to run that machine. Real common with lathes, with metal lathes. And so there'd have a lift, a lever that would shift it in and out of gear. And so this is my constant power source. And so that's driving the counter shaft. And so this is, again, a previous episode we talked about.
But say it again, because some of these folks haven't watched
Yeah,
it.
and I haven't heard it either.
Oh, repulsion
well,
motor?
Shame on all of you. Yeah, this is a repulsion start induction single phase motor. And I know just enough about that to be dangerous, and I found a way to make it more dangerous. But
Perfect.
this thing starts in a certain mode, and then it shorts itself out internally in such a degree that then it goes into a different mode. And the motor guys can tell you exactly what that means.
Sure.
The advantage of this is a real high torque in doing that when it starts up, which we kind of don't need because the torque is wasted because the belt starts slipping immediately. If it was direct drive, that'd be a thing. You'd want that torque to work for you. Torque is kind of lost here because the belt loses all that energy. And we had to wire it up somehow, and I like old everything.
Yeah, hooray.
So I said, I'm going to go knob and tube on this whole thing.
Where did you find those boxes and gate all that? Is that?
I have a freakish attraction to old electrical, and I find it everywhere. That color hammered starter there is about the same era as a motor, about 1948, 49. The meters I put on there for fun. This one is showing it's running just under 240 volts. That's what the thing is wired for. This is amperage that I can watch when I'm under load here. Those are just for fun. Those are unnecessary. This is kind of a tip of my hat towards big operations that would have a whole switchboard and a whole power
Do
board.
you know Clay Jordan? Did you know him?
I did not know him.
He's dead, but he has a whole panel of old stuff that he'd hooked up for converting three-phase or single-phase to three-phase.
Through old stuff.
And
I would love it.
he had done it prior to all the experimenting I did with it to get mine going. But of course, I didn't do any of that, but he's got this whole thing of all these cool old dials and stuff. And it is.
I just love that stuff.
Yeah, it's cool.
I just love that stuff. So this is what they call knob and tube. In this configuration, I don't know if it's even called knob and tube, because knob and tube means you had knobs very similar to this, that then the wire would go through the single conductors here, right? One is hot and one is neutral. In this case, both are hot because it's 240.
And you're running this big ground or big neutral or whatever you want to call it.
It's a ground, yeah.
But you're coming clear from your power source with it, and
Yeah, the big challenge with all this stuff, it's not grounded, and I'm okay with some measured danger, but I still think grounding is not a bad idea.
Well, you're going to have grandkids in here
I
fiddling
know,
around.
and guys like you in here
Yeah,
that
that's
don't want
right.
to get electrocuted. Well,
That's right.
I don't know. We'll see how that
Yeah,
goes.
yeah.
Let's see how
But I
that
mean, those are hot right here on the
Everything's hot
termination.
right now,
So
yeah.
in terms
Yeah.
of grandkids, you got
Yeah.
Exposure.
you
Don't
got-
touch grandpa's stuff.
Yeah,
Stay out of the shop.
they're screwed either way.
you only do it once.
Ground is the least of their problems.
So depending on which direction you want to go with this, coming down, let's say, the power is coming down to the starter here. Then the starter, this actually has a heater and all kinds of stuff that is really a real life motor starter. That's why I did it, because it's matching this. Unnecessary for my application. But it goes down here and I fused it. Those are fuses which are unnecessary, but they're just cool.
Yeah,
And
they
so
are.
that's why I put them on.
Yeah,
Absolutely.
how many screw-in fuses do you find anymore?
Not
This
that
stuff
many.
is, I had to have that on there. So I put those and wired it in there, and
I'm just
rest is history.
compelled by the elegance of those brackets holding up that jack shaft.
that's remarkable.
Yeah, oh, isn't it though?
Yeah,
Yeah.
it's stunning. It's stunning workmanship.
So these little insulating glass, whatever, are those things you scrounged up, or can these be like these?
Yeah, I went to the hardware store called eBay, and they actually, that is a particular one that I was looking for. I can't remember what it's called, but it's for this application, where I'd have these two together. Knob and tube, I think a lot of people have seen them. They're a round ceramic knob that has a hole. I wish I had one to.
There's a nail that goes through the middle of it,
through
so you
it,
can
Yeah.
nail it to a
Actually,
joist.
if you want to stop, I can show you what that is. Would that be helpful?
Yeah.
Yeah.
Go grab it.
So this is knob and tube. So when you hear knob and tube wiring, that's what this is. So this has a slot in here for both conductors to go through, and that would be nailed to the wall.
Oh, cool.
And then this, when you went through a framing member, through a rafter or something, you drill a hole and poke that in there, and that's how you went through and insulated it inside the wood. So that's why it's called knob and tube.
Wow.
And for this application, that wouldn't work because I didn't mind having the knobs, but the tubes I couldn't fit in. But these are a surface mount that do the same thing, and they keep the conductors separated. Actually, it looks really dangerous, and it is if you touch, the live connections.
Yeah.
But from a safety perspective, it's one of the safer ways of wiring. In fact, back in the 80s, I was talking to a guy owned an electrical shop. I was wiring my home, and he said that there was a theater that specified knob and tube wiring, a modern theater, because the conductors are so far apart they can't short out. And so from a fire perspective, they spec that whole thing in knob and tube.
Wow.
In
As
modern.
as opposed to like a piece of Romex where they're like
They're right next to each other. Yeah, and so
And the
ratchets
rats
into
chew
it,
into 'em
and all
and
of a
they-
sudden you've got something that sparks there. And how many fires are electrical fires? Probably 80%.
Yeah. That makes
Where
sense.
this, they're way separated. Now, it's dangerous because if you touch, live things here, you're going to feel that.
That is cool. Wow.
All right, put that
It wouldn't
belt on.
matter, Nate, to probably anybody, but you see how he's got this grounded onto the frame of the.
Yeah, big little copper bus is so tidy. So
And I did a
cool.
continuity check with the motor and everything. So everything that's in metal contact is all safe, in quotes. I'll say it's grounded. The drill's unnecessary to ground it because it's not
Yeah.
connected to anything here.
And in your shop, it's probably run into a panel anyway, so you can hit the whole thing off on a breaker and.
Well, we should show that, should we?
Do you
Yeah.
get static? Do you get static off any of this stuff?
That's a great question. I don't think so, but
I get
think
static
it's
off my
possible.
belt sanders.
I think it's possible, yeah.
every once in a while I get a spark coming off of that belt sander.
Yeah.
I don't know why it builds up.
That's just friction. I bet that's just at
Were
the
these
shiv.
pulleys like,
And you
like
think
originally
Like
for
the
drill,
helicopter
or
blade.
just
It'll
kind of
jump
like
that far to my hand.
all-purpose
Yeah.
Pow! It'll hit me.
used
I
for
bet that's
whatever
like
they-
helicopter
Yeah, those
rotors
are a
in the air.
line shaft. That's a whole discussion in themselves. They're mounted upside down right now, which it's still an appropriate way to mount them, but they're designed to be hung. And when I envisioned this to happen, these brackets were going to be turned the other way, and I was going to hang these, but it just got too busy down here, and so I
Yeah.
decided to go the other way.
Yeah, makes sense.
So they have that's a whole discussion. There's a shifter mechanism there with that. So those particular, what we're going to call those, basically bearings or whatever they'd be, housings, could have a shifter on it for a machine.
Oh,
In my application, all they're doing is just holding that shaft.
But if you bought this drill, it's not going to come with these.
It's
It's kind
not.
of
No, that's-
assumed
I
that
get
you'll
where you're
rig
at
it
now.
up like
Yep.
with your own parts and pieces or buy what you need to hook it up.
You're going to get this pulley. Actually, you're
Oh,
going to
that
get two
pulley.
pulleys. They're right next to each other. It's called a fast and loose,
Got
or
it.
alive and dead, or there's different ways of looking at it. And one was fixed hard on this like this. The other one was loose and would spin. And in fact, over here, this is a fast and loose pulley setup. This is another project I have for a grinder. So one of those is loose and one is solid. And then you'd have a matching set of those up above, and you'd have a lever with arms on it like this that would shift back and forth. And so it would stay in the neutral position, just spinning freewheeling here. And as soon as you shift that over, the belt would roll over onto this and then energize this.
Oh,
And
because they're a
that's-
little neutral.
yeah,
Cool.
so my application, I don't have that. I have just a single one. That's the same diameter. I think it's about 8 inch.
Did you say fast and loose?
Fast and loose.
Is that what that kind of expression?
Yeah.
Is that even fast and
It
loose?
probably, most things, like milling, for example, grist milling, keep your nose to the grindstone and all that, is because you want to smell so the stones aren't making contact, because that could blow up the whole mill. So
Oh.
we have a lot of things
I
that come
didn't
out
know
of
that.
Yeah.
That's cool. But the fast and loose as a euphemism, as I understand it, is just you're doing it as quickly as
Yeah,
you
it
can.
works like that also.
But this fast and loose is like hold fast.
Yeah,
The
yeah.
fast one is
Like
fixed.
fast and
Fixed
fixed.
and loose.
Tight.
And then the other one's loose.
Yeah, yeah. So here's an interesting thing, that these flat belts or flat shivs are crowned.
They are.
They're high in the middle
Yep.
because the belts run to the high side.
Yeah.
And so when it's crowned in the middle, the belt centers itself, which took me a while to figure that out.
I
In an
still don't know
earlier
how
life.
it works. That's some kind of sorcery I don't understand
Yeah,
right there.
yeah. Why?
Well, it's just logical,
For you it is. Tell us why it's logical.
because if it goes off to the side, it wants to go back to the center. It always wants to go to the center. And on my big hammer, that pulley's so flat, it's worn out, it's lost that, and I had to put a flange on the side of it to keep it
keep
from
it on
running
board.
in.
Yeah.
So
Well, I had the same thing here, and this is pretty common. I've experienced this in other drives. This is going so fast and it's spinning, it wants to spit this belt off.
Yeah.
And what it would do before I put these little keepers on here is it would come over here and ride a while and then climb back up on there again.
Oh.
And I figured all I'm going to do is wear that belt out doing that.
and the keepers wear it too, because that flange wears my belt.
Yeah, each
Yeah,
side
because
of it away.
that belt's still moving. It just can't go as far this
Right.
way.
But I've got a new belt on that now, and that new belt is so nice that it doesn't run off.
A lot of it has
Probably
to do with
lacing.
alignment to get the alignment working
and
right.
I
and
have to
everything.
align mine by the jack shaft, because I put a jack shaft in it to slow my motor down to 800, because that's the way it was built to go, and I
And the
burnt that
lacing
motor
has
out.
to be square and,
Right.
and
Yeah,
and-
everything
yeah.
has to line
But it's
up.
running perfect now.
The one that I went with here is called Clipper. There's Clipper and Alligator. That's the one you hear the most for guys like me that are in this world. And they're different sizes, and it's all based on belt thickness. And what it is, it's a continuous strip of this stuff. And so it goes together like this. And I have a clamp in here, so you'd cut this out and you put your belt in here, and then you pinch it in a vise, on one, well, we can go around here and see how this looks, right? So this has teeth in it right here, and these teeth are hidden in behind here, but once, this is just a keeper that keeps them from all getting separated because they're individual little clips. And so they bite on one side, and then this bites on the other side. And then when they come together, it has this cord. You can also use a pin. You can use a welding rod. Ask me how I know that. And that holds it together. What's nice about this is it's a quick way to do a belt. Now a continuous belt is what they call vulcanized, which actually they chemically weld it together. In fact, there's even heat
So
involved.
it's endless.
It is endless. The belts stretch over time. And if I use this thing a lot, this would get real floppy. And the solution is I would just cut this off and I'd put a new section on here and shorten this belt up. And it's a way easy field fix. And do any kind of maintenance or anything, if I got to pull all this apparatus apart, I just pull these pins out and these belts just fall away. And it's a real nice way of doing it. These are small. They can
I
get
was
big.
telling Scott, sometimes originally that pin was made out of rawhide.
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 Interesting.
And double. It was 2 strips of rawhide that went in there together. You wouldn't think it'd be that strong.
Our friend Mr. Harris would be interested in that, wouldn't
Yeah,
he?
you would.
Yes, these get big. There's
Oh, wow.
there's a bigger one there for a big thick belt.
Jeez.
This is an alligator here. The difference is it's too big for the vise, and you just put this on an anvil and you just beat the thunder out of it, and it pinches it.
So that's a conveyor belt rather than power
Yeah, that's a big,
transmission.
heavy conveyor belt, and so that's the beast you're looking at there.
Wow. Oh, that's cool.
Yeah,
Wow. These look like they're from back in the day also.
they are. Yeah, it's this weird stuff that collects itself to me. And there's the size of the pin there. I mean, it's
Wow.
very, very big when it's all said and done.
Wow,
And this
cool.
is even bigger yet. This is next size up.
Jeez. That's cool.
So that's that part.
The one I've got on my belt now bolts on.
Oh, okay.
And I got it from the sawmill guy, and Millwright lent me the gate or the die to put it together with, so I could keep it straight. And the tools all.
And once it's bolted in, you're good to go.
Yeah.
And then if you need to, you unbolt it,
It
take a section out,
doesn't
bolt it
make
again.
much noise. It's quieter than I ever thought it would be.
Yeah, that's a good point. In shops like this, you can hear it going click, 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 or depending on what the RPM.
Mine goes
and that's
clickety,
that
click,
metal
click, click.
that's hitting that metal going around each time.
So it kind of seems like you got this set up in a way that this is going to be your drill for your shop. I mean, is there any reason that you're going to use some other drill press besides this? When you
I have a
got
small drill press that I use for 99% of the time, which is everything up to 1/2 inch.
Okay.
It's just faster and easier and better.
Yeah.
One thing I don't have is a freestanding, a regular drill press, which I need to get
big
for
one.
heavier stuff. What this will do, it was advertised as being able to go up to 1.5 inches in diameter, and so
Wow.
my little drill press won't do that.
Wow.
So if I want to do heavy drilling and have some fun with the drill, which I'll do, then this will be the machine for that.
And that power feed makes it so you can hold on to things with both hands and click that in. Scott and I drilled how many 100 quarter-inch
I think
holes
there was
one
two-
time?
I think there were 2,000 holes in that set of.
And we set up benches on both sides of my big radial arm drill, and we had it so we could just slide things back and forth, and you just click it in, it goes boom. You click it out, and it goes boom.
Yeah.
It's really handy and does a good job. And not only that is, it doesn't suck. Like a lot of times you clamp that down, but if you don't clamp a piece of lightweight stuff down, it will tend to jerk it. Well, it can't jerk that power feed down because it's geared.
It's holding back at the
Right,
same time
it's
it's
holding
pushing
it
down.
at the same
It
back.
goes at the speed that
Yeah,
it wants
it goes
to go.
in at whatever you said at 3,000ths or you said at 15,000ths. That's the speed that it goes down.
Show us a couple of the things. I mean, you talked about building this eccentric.
Yeah.
We've got all these Babbitt bearings here that are working beautifully after being cast. Is this the aluminum knob or? I can't even tell.
This the aluminum. That's good. See, that
Yeah.
means I did my work.
You did your
That's
work.
the aluminum knob there.
Yep, that's aluminum. This is cast iron. The function is beautiful on both of them. Wow.
And again, if this was a real drill in a real world working environment back in 1908, 1910, that should be cast.
Sure.
Because it's going to hold
Because the
up.
same guys that did this would wear that out.
Absolutely.
Yeah.
This is going to, those threads are going to wear out eventually.
Sure. Okay, so where is that shaft that you had the insight to buy continuously keyed and then just fill the portions that you didn't want to have keyed? What shaft is that?
That is on the motor.
Okay, it's down there, yes.
Yeah. So what's happening here, I could have done this different ways. I just got on my MasterCard and bought a continuous keyed because I had a lot of stuff here that needed to be keyed in. For example, that 3-inch wide pulley needed continuous key. I could have tried to machine all that and whatnot, could have done it. But what I decided to do was to do it this way. And then I put some key stock in here and I drilled and pinned that in the shaft. And then I went to my lathe and I turned that down. So these bearings think that that is a solid journal because that's pinned in there. I was going to silver solder it, and I think I talked about that in a comment. I decided that's from the Department of Redundancy Department.
Redundancy department.
It just was silly.
Yeah, and it's working beautifully.
It is, because let's talk about the oil. I talked in the previous video that a Babbitt bearing is not running on the bearing, it's running on the oil that is on the surface of the bearing. Mm-hmm. And if it ran on the Babbitt itself, Babbitt is much softer than the steel, and this would wear out almost immediately and start to wobble and destroy itself. You got to keep these oiled because that thin layer of oil is what the actual bearing surface is that the steel is running in. Mm-hmm. And the Babbitt is just basically holding that oil into place. Mm-hmm. And then when it does run dry, you want a material that's soft enough that won't destroy your shaft.
Yeah.
Because when you get old Babbitt bearings, they're all wallered out. Why is that? Well, they didn't oil them. They didn't take care of them. Or they use grease instead of oil.
Oh, and that wouldn't run around and circulate
And most
everywhere.
guys, they see a Zert fitting and they put their modern grease gun there, fill it full of grease, and that's not what you do. That was an oil Zert fitting.
Okay.
And so you would oil that. The grease is too heavy. This oil it is in between. The kind of the gold standard for lubricating oil for this is called green velvet. And it was made for years and years and years, and it was a very sticky, like a 30 weight oil, and they added tallow to it, and they wanted it to stick, kind of like Waze oil. They wanted to stick on there because centrifugal forces wanted to throw that oil out all the time.
Yeah.
There's nothing holding it. A sealed bearing is a sealed bearing. That can't go anywhere.
Yeah.
This wants to spit that out constantly.
So you got to keep on it. So
So there's one source on the old interweb that is able to get this, and it's...
You might say too, Dave, that they had grooves in those Babbitt bearings.
Yeah, that's the important thing when you're doing fresh Babbitt pour. Once you clean it up with a scraper, you have to scrape enough to where you're not making complete contact. There has to be enough room for that oil. Mm-hmm. That's a little tiny bit, but still you don't want it to be really biting on there because it's going to scrape the oil off. So you want a little bit loose so the oil can run, but not so loose that you lose tolerance. There's a fine line there. So once you scrape that out, then you want to go and you want to put oil grooves in that Babbitt. And so that oil is going to kind of float in there. Then on top of that, these holes are packed with a felt material I get from a master car. Through the years, it was different things. It was there was a product left over the cotton industry that was jammed down in there. So you load that up like a wick, and basically
you soak up the cotton and
yeah,
you keep painting it on there.
and that keeps that lubricated all the time. So you're not constantly have to do that. But this is that green velvet.
Is that visually any different than just any 30 weight that
Well,
we would
it's
see?
green.
Oh, look at that, yeah.
And you can feel it is sticky and it's thick. And I don't know, there's a recipe for it, a formula. I don't know if they still use tallow for the guy that's doing this or not, but anyway, it's designed.
It does feel,
It's going to stick to that better.
yeah, and it wants to make
My
it
grandson rendered out about 4 gallons of beef tallow. No, 1.5 gallons of beef tallow the other day.
Yeah.
Are you familiar with green velvet?
not.
Has that name ever come up in your world? It's new to me. I
I
researched it out.
have a couple bearing scrapers, and I've used them. but sometimes they had little, very beautiful brass and glass containers that had the oil in them and a drip thing on them that you could control.
A little cup.
It's a not a cup. Well, it's kind of a cup, but it's enclosed, and it has a screw top on it that regulates how fast
Oh, it
the
drips.
oil will run.
Like that.
Yeah.
Like that. Look at that. See that thing?
That glass is broken, obviously,
Yeah, yeah.
that one, but
Yeah, on a bigger machine, more critical.
And you see the glass at the bottom there on the thing?
Yeah, oh yeah.
That's a visual thing, so you can see how
in
fast.
different sizes. Here's a different size.
Oh, look at that.
My blacksmith blower, I've got one on top of it, a little one. Yeah, keeps the liver kitted. And you set it up just to drip however many drips you want.
Whatever your instinct is for how much
Like
you're-
the blacksmith blower has no seals.
Sure.